Wagwan people, and today we are looking at the creation of the universe, and as well as that, actually how it has evolved to be like it is today. So let's start off with just a bit of information about cosmic microwave background. This probably should be somewhere else, but it has a peak intensity of 0.011 meters, so something actually quite relatable. We could visualize that. Has temperature of 2.7 Kelvin, which is pretty damn cold. And if we monitor our cosmic microwave background radiation, it's going to be basically the same everywhere, and it's going to be the same in all directions. And this is good evidence for the Big Bang, as we'll look at later. So basically, timeline of the universe, back really soon after the Big Bang, 10 to the minus 43 seconds, we basically have no idea what happened. Stuff happened, we don't know what. And to probably we're never going to work it out. Like we can think about it. People think that the universe may have been infinitely hot, infinitely dense and whatnot, but we never know for certain. Then when the temperature was approximately 10 to the 12 kelvins and the time was still really small, 10 to the minus 43 to 10 to the minus 4 seconds, this was the time when quarks, leptons and photons formed. So this is the fundamental building blocks of our universe. And very important to note that there was slightly more matter than antimatter. We don't know why that was, but clearly as we're living in a matterless universe, we know that. So, but when the temperature was 10 to the 9K, still bloody hot, and the temperature was approximately 10 to the minus 4 seconds, quarks could form to make hadrons, and matter and antimatter collided and annihilated. This emitted many high energy photons. When the temperature got a bit cooler and the time was 100 seconds, fusion began to occur, which made helium and lithium nuclei. However, this fusion occurred in plasma form, which means these nuclei didn't have any electrons orbiting it. When the temperature was 10 to the 4K, and over 250,000 years had passed, electrons finally joined to make hydrogen and helium atoms, and photons could now freely travel the universe without being constantly absorbed and emitted. When the temperature was a mere 6,000 Kelvin, so we're getting quite cold here, and 1 million years had passed, but we could start to see some fluctuations in density of the universe, and this is where we start to see galaxies beginning to form. After 1 billion years, the temperature was only 17 Kelvin, which is quite cold, like really cold. And heavier elements like lead and iron were able to form due to the gravitational collapse of stars. So until this point, basically everything had been quite light, but now due to stars dying, they get heavier. And that brings us to the present day, where life is 2.7 Kelvin, 13.7 billion years have passed, and we have a lot of protons compared to our neutrons, and this is due to the prevalence of hydrogen, which in our universe, which has not many protons and many neutrons, but due to beta decay, that is of course constantly changing. And now let's look into the future. There are three main theories for how the universe may die, and these can be calculated using the critical density, which is basically just the sea of constants. The critical density is apparently 3 times Hubble's constant squared over 8 pi gravitational constant. Don't know why that is, I'm not going to derive it for you. And basically, yeah, that's the critical density of the universe, which is about equal to 6 hydrogen nuclei taking up a meter squared, so quite not dense. If the universe has a density greater than the critical density, there is going to be a big crunch, which is basically where the universe collapses back on itself, gravitational forces due to mass are too high to, and it comes bang, and yeah, basically maybe that will become a cycle of another Big Bang. If the universe is of the critical density, it will slowly expand to a limit, but it will constantly expand, and if we have a density greater than thing, it'll expand forever. Thank you for watching, and bye-bye.